Hello children, welcome to my class. I'm Jabashri Ghosh, teacher in Demonstration Multipurpose School, Bhubaneswar. I'm really happy to have you all with me, and I'm sure you're also waiting for my class with your NCERT books, notebooks and pens. Today you need it really children, because in this part we will be discussing very important concepts, and that too we are going to solve certain numericals. So children, let's start our class. Okay. Today we'll be discussing molecular mass, Avogadro number and mole concept. Let me tell you children, these are the most important part of studying about atoms and molecules, and even if you are studying science in your future also, you will need these forever. Okay, so listen to it minutely and be attentive in the class with your notebooks and pen. Okay children, but before moving to those concepts, you know what I do? Just brush up what we had done in our last class. What is that recapitulation part? Yes, we had learnt about molecules. You remember children what are molecules? I know you remember, but let me remind you a bit. It is the smallest particle of an element or a compound which is capable of independent existence. I told you about that. It can exist independently, and some are there which cannot exist independently. Okay, like some inert gases, they are noble gases, they don't hold hands of others. But there are some other gases like oxygen, nitrogen, chlorine. They cannot stay alone. They need somebody. Like they can need their own brothers and sisters. Like with chlorine, oxygen, they can form molecules, or they also take the help of their neighbors. Sometimes chlorine with hydrogen, sometimes carbon with oxygen, to become molecules and be stable and independent. Okay. So, these molecules show independent existence and shows all the properties of that elements or the compound. Okay children? Then, we had learnt about atomicity. What is that? Yes, you remember, I know. The number of atoms present in a molecule of an element or a compound is known as its atomicity. Ions, same during electrolysis, positive and negative. Yes, the molecules of the compounds composed of metals and non-metals contain charged particles called ions. They are cations and anions. Valency, the most important concept. The combining power of an element. It can be used to find out how the atoms of an element will combine with the atoms of another element to form compounds. And children, we have also learnt using these valencies how elements form bonds with each other. Today, we'll start with molecular mass. Now you have known what molecules are. Then we are studying molecular mass. Before that, you have studied atomic mass, and I have warned you several times. You have to remember those atomic masses at least for the first 20 elements, and I know you remember it now. In all the classes we have discussed about that, so I am sure you remember it now. Molecular mass of an element is defined as the sum of the masses of the elements present in the molecule. And it is the sum. Different elements are present, so we have to add up the masses of all the elements. Molecular mass is obtained by multiplying the atomic mass of an element with the number of atoms in the molecule, and then adding the masses of all the elements in the molecule. When we go for the example, children, you will understand it very clearly. Don't worry. The formula unit mass of a substance is the sum of the atomic masses of all the atoms in a formula unit of compound. It is formula unit is nothing very great thing. It is just similar to finding the molecular mass of a compound. But the main thing is that when we find the molecular masses of the ionic compounds, we say it is the formula unit mass. Nothing more. So don't be scared. We use the word formula unit for those substances whose constituent particles are ions. Okay. For example, molecular mass of H2, hydrogen gas. Okay. H2 means atomicity is 2. One atom of hydrogen, atomic mass of one atom of hydrogen is 1 unified mass or 1U. Here 2 atoms of hydrogen are there. So 2 into 1U is equal to 2U. What about oxygen? 1 atom of oxygen, atomic mass is 16U. Here we have 2 atoms of oxygen. All of you use your notebooks and pens. I am repeatedly telling you children so that you can solve it yourself also. Just see the examples on the screen and you start doing it on your notebook. O2. 2 into 16U is 32U. What about CO2? Carbon, atomic mass is 12U. You have 1 atom of carbon, so 1 into 12 plus. How many oxygen atoms? You have 2 oxygen atoms. For 1 oxygen atom, 16U. For 2 oxygen atom, 32U. When you add them, it comes out to be 44U. Okay, children? This is the molecular masses of several compounds or molecules. Now, formula mass unit. How is it different? As I have told you, just ionic compounds. These are the ionic compounds. NaCl. Okay. Sodium. What is the atomic mass of sodium? 23U. What is the atomic mass of chlorine? It is 35.5U. Okay. So, combinedly we have 58.5U. NaCl. Al2SO4 whole thrice. Aluminium sulfate. Aluminium. What is the atomic mass? 27U. How many atoms of aluminium are there? Al2 means 2 atoms. 2 into 27U. Then we are adding, see here children, SO4 bracketed whole thrice means S has got 3 atoms and O has got how many atoms? 4 into 3, that is 12 atoms. I had discussed that in the earlier class. So, in this 2 into 27 for aluminium, 3 into 32 for sulfur and 12 into 16U for oxygen. When combine all this, we add it up, we get 342U. You solve it in your notebook and you will find the same answer. Children, try it on your notebooks. Then comes calcium chloride. Calcium, atomic mass is 40U. 1 atom of calcium is 1 into 40 plus chlorine, you know, 35.5 for 1 atom of chlorine. But here you have 2 atoms of chlorine, Cl2. So 2 into 35.2, it comes out to be 70. 70 plus 40, it is 111U. Children, this is on your screen. If you want it, we can have it for a few seconds more. Just have a keen look at it and listen to me minutely and you can understand. This is a very easy concept. Once that concept gets into your mind, children, you would never forget. Okay? So, can I move forward? Yes, let's move forward. Now, one more concept is there, mole and Avogadro number. Mole concept. Okay? What is this mole? M-O-L-E. What is this mole? The mole is the unit of measurement for amount of substances in the International System of Units, that is SI unit. You have heard about SI unit? Yes. In SI, International System of Units, moles, it has been suggested to be the unit of measurement for amount of substances. Okay. From where they got this word mole? The word mole is derived from the Latin word moles, means heap or pile. Pura, like piles of thing, hill of something. That is because it's a very large number. You will come to know it's a very large number. Children, let me tell you about moles. Suppose you are going to a shop and you are asking for give me 1 dozen bananas. Okay. So, how many bananas you ask for? You are asking for 12 number of bananas. It's not it. Dozen. The word dozen signifies 12 number. It's not, it's a number. Suppose somebody goes to the market, he has got a like wholesale sort of thing. He is going to sell lots of things. He is asking for 1 gross of eggs. Gross means 12 dozen, means 12 into 12, 144 numbers. That person is asking for 144 numbers of eggs. He has got a shop and he wants to sell them off. Okay. So, this word dozen, this word gross, what does it mean? These are simply counts or the numbers. Similarly, the word mole is just a count for the number of particles. And how many numbers? Let's see. The mole symbol MOL is the SI unit of amount of substance. 1 mole contains only, I'm saying only, 6.022140076 into 10 to the power 23 elementary entities. You can imagine how many numbers? Big number. It's a very, very big number. But children, this number 6.022140076 into 10 to the power 23 is known as Avogadro number. It's a large, huge number. And it's named after the Italian scientist Emilio Avogadro. Let's see who this Emilio Avogadro was. Children, in all my classes, I give a bit introduction about the scientist. This is to enhance your general knowledge. And one more thing, what I feel, you will be inspired by their work. And sometimes in future, we may see some of you have become much bigger scientists than these people. Okay? So, all the best, children. Lorenzo Romano Amedeo Carlo Avogadro, born on 9th August 1776, and he lived up to 9th July 1856. Count of Quaregna and Cerreto was an Italian scientist. He was a count and Italian scientist. He's a noble person. Most noted for his contribution to the molecular theory, now known as Avogadro's law. In tribute to him, the number of elementary entities, means number of particles like atoms, molecules, ions, all other particles in 1 mole of a substance, that is 6.022140076 into 10 to the power 23, is known as the Avogadro constant. One of the 7 SI base units and represented by capital N with a subscript A. Okay. This figure 6.022140076 into 10 to the power 23, children, we just have rounded it up, and generally we use 6.022 into 10 to the power 23 as the Avogadro's number. Okay, 22, sorry. Now, mole is a numerical quantity. As I have told you, like 1 dozen, 1 gross, mole is also a numerical quantity that has a mass equal to the atomic or the molecular mass of the species. Which species? It may be atoms, it may be molecules, it may be ions, or it may be the particles. Here also you have to remember the atomic masses and the molecular masses. 1 mole of any substance is equal to 6.022 into 10 to the power 23 number of particles. Don't forget. It may be number of atoms, it may be number of ions, or it may be the number of molecules. Gram atomic mass of a substance. For this you have to know the atomic mass. When you are finding the atomic mass, you know the atomic mass, you can find this gram atomic mass also. And to find the gram atomic mass, you have to know the atomic mass of all the elements. The atomic mass of a substance when expressed in grams is known as its gram atomic mass. How do we express the atomic mass? You remember, children, what we had discussed? Yes, first we had done it by AMU, then we call it U, that is the unified mass. Those just unified mass, when written in grams, it becomes the gram atomic mass. Okay? Now, gram molecular mass. You can find the molecular mass in U. When that is converted to grams, it becomes the gram atomic mass of a substance. The molecular mass of a substance, when expressed in grams, is known as its gram molecular mass. See here, children, it's very easy. Gram mass of an entity is known as molar mass. Okay. Gram mass of an element, or it may be of a compound, we call it molar mass. See here in the example what you see. First we have the categories of elements: carbon, hydrogen, oxygen, sodium and chlorine. Then we have the average atomic mass. Why the word average is written? Because for carbon it is not exactly 12, it is 12.0005 or something is that. And for H, 1.008, some decimals are there which can be neglected. So for element carbon, average atomic mass is 12U, but when this 12 molar mass becomes 12 grams per mole. Okay, molar mass becomes, if carbon has got average atomic mass as 12, its molar mass becomes 12 grams. 1 mole of carbon means 12 grams of carbon. It contains how many atoms? 6.022 into 10 to the power 23 number of atoms. Similarly, hydrogen. Atomic mass is 1U. Molar mass is 1 gram per mole. And 1 mole of hydrogen contains 6.022 into 10 to the power 23 number of hydrogen atoms. Don't forget. Similarly, 16 grams of oxygen contains 6.022 10 to the power 23 number of oxygen atoms. That is 1 mole of oxygen. Sodium, 1 mole of sodium has got how many atoms? It is 6.022 into 10 to the power 23. Similarly, 1 mole of chlorine has got how many atoms? 6.022 into 10 to the power 23 number of atoms. And what is the molar mass? 35.5. That is 35.5 grams of chlorine contains 6.022 into 10 to the power 23 number of chlorine atoms. Clear, children? Just keep in mind, the molar mass of an element, 1 is 1 mole. Okay, 1 mole of that amount of element contains Avogadro's number of particles, that is atoms. Okay, children, let's go for an example and see. 1 mole of carbon atoms, as I have told you, it contains 6.022 into 10 to the power 23 numbers of carbon atoms. What is the weight of 1 mole of carbon atom? That is 12 grams of carbon atom. So, how do we say 1 mole of carbon atom means 12 grams of carbon atom, which contain how many carbon atoms? In that, 6.022 into 10 to the power 23 number of carbon atoms are present in 1 mole of carbon atom. Okay, or 12 grams of carbon atom. Similarly, when we consider 1 mole of sodium chloride molecule, NaCl molecule, it contains 6.022 into 10 to the power 23 number of sodium chloride molecules, or 58.5 grams of sodium chloride molecules. So, this is gram atomic mass and Avogadro's number of particles, okay, in 1 mole of that substance. Children, when we'll be dealing with certain numericals in this chapter, you are supposed to remember these formulas. It will be better for you for solving the numericals. Please note it down, children. Suppose n, small n is the number of moles, small m the given mass, capital M the molar mass, capital N the number of particles, which is given number of particles, and Na, you know, is the Avogadro's number, that is 6.022 into 10 to the power 23. Now, what are the formulas to be used? When you are supposed to find the number of moles when mass of certain element or compound is given, that is N is equal to given mass by molar mass. Okay, those are formulas which are written in red. Please note it down. Number of moles, number of particles divided by Avogadro's number. This is one more formula for finding the number of moles. Suppose you are supposed to find out the mass. Mass is equal to molar mass into number of moles, that is small m is equal to capital M into capital N. If you are supposed to find out the number of particles, how would you find out? You will have to find out first the given mass per molar mass. What is that number of moles? Into Avogadro's number. Other way of finding out particles, number of moles, you know that same number of moles into Avogadro's number. Okay. Children, please note these formulas and you use it in the numericals which we will be doing now. Now, we start with the numericals. Okay. First question is compare 1 mole of hydrogen, 1 mole of oxygen and 1 mole of fluorine. Which has the highest number of molecules? Explain why. What do you feel, children? Which has the highest number of molecules? How many molecules are there in 1 mole of hydrogen? Yes, it's 6.022 in 10 to the power 23. What about 1 mole of oxygen? Same. What about 1 mole of fluorine? Same. So, which has the highest number of molecules? All these have same number of molecules because 1 mole contains 6.022 into 10 to the power 23 numbers of those entities. Okay. I had told you it's a number. It's same in all 1 mole of anything. 1 mole of ABCD, 1 mole of this whatever water, 1 mole of oxygen, 1 mole of carbon. They will contain same number of particles. 1 mole of atom means same 6 Avogadro's number of atoms. 1 mole of one molecule means Avogadro's number of molecules is present in that. 1 mole of iron means Avogadro's number of ions are present in that. You get my point, children? Which has the greatest mass? Explain why. The element which has got the means atomic mass is more, that will have the greatest mass. Which has got the atomic mass more? Of course, it's fluorine. Hydrogen 1, oxygen 16 and fluorine is 19. Okay. So, fluorine has got the greatest mass. Calculate the molar mass of each of the following compounds. You have to learn this, children. See here, molar mass. It's very easy. Once you see, start doing, keep your pens and notebooks ready. You start doing along with me. Hydrogen fluoride, HF. What is the molecular mass? For hydrogen, 1U. One atom of hydrogen means 1 into 1. Fluorine, 1 atom, 19. That is, the atomic mass of fluorine is 19. 19 into 1, it will give 20. Molecular mass is 20 U, but molar mass, it is 20 U means it will become 20 G. Simply I have told you, just replace it by molar mass. When you are finding, you replace the molecular mass just by G. It becomes 20 G. Similarly, case of ammonia. Nitrogen 14 into 1. Hydrogen 3 into 1, 17. It becomes 17 grams. Nitric acid, H, N and O. Three types of elements are there. Hydrogen 1 into 1. Nitrogen 14 into 1, but in oxygen, O3 means 3 atoms of oxygen. Atomic weight mass is 3. So 16 3s are 48, and when we add up, we get 63. Similarly, silver sulfate, Ag2SO4. 2 atoms of silver. Atomic mass of silver is 108 U. 2 atoms means 108 into 2. Sulfur 1, 32 into 1. O4, 4 into 16. And it comes out to be 312 grams. You also do it on your notebook so that you can compare this value. Similarly, boric acid, S3BO3, 1 into 3. For boron, atomic mass is 10.8. 10.8 into 1. And for oxygen, similarly, 16 into 3, that is 61.8 grams. Is there on the screen for 2 seconds, children? So, I think you have noted it down. Next question. Calculate the number of moles of the following. Number of moles. How would you find the number of moles? You remember the formula? Is the given mass by the molar mass. Given mass 52 grams of helium. Given mass is 52. Helium. Molecular mass of helium is 4 units. So, molar mass becomes 4 grams. So, what is the number of moles? 13. 52 grams of helium means it is 13 moles. Then, one more type. The other formula we are supposed to use. We are supposed to find moles of 12.044 into 10 to the power 23 number of helium atoms. Here particles are given. Number of moles is equal to given particles divided by Avogadro's number. What do we get? It's 2. So, number of moles is 2 for these particles of helium atoms. Simply, we are substituting the numbers in the formula. One more. Calculate the mass of the following. What is the given? 0.5 moles of nitrogen gas, N2 gas. Here moles is given. Okay. You have to determine the mass. Mass is equal to molar mass into number of moles. What is the molar mass of N2? N is 14, N2 is 28. Okay. Atomic mass of nitrogen is 14. You remember? 2 atoms of nitrogen N2 means 28 into 0.5. You have 14 grams. Mass is 14 grams. So children, when you are supposed to find the mass of 3.011 into 10 to the power 23 nitrogen atoms, what you have to do? The molecular or the atomic mass of nitrogen is 14 into given number of particles divided by the Avogadro's number. We have 14 into 0.5 and that comes out to be 7. You can also do its very easy calculation. 3.011 is just the half of 6.022. Okay children, let's proceed to the next numerical. You have lots of numericals in this chapter. It's simple. If you understand the concept or you remember the formulas, you can very easily do this, children. Don't get frightened, you can do it. Calculate the number of particles in each of the following. Number of particles. I'm talking about the number of, it may be atoms, it may be molecules or whatever is asked. 46 grams of sodium atom. Okay. Now, number of particles, if we go by the formula, what is that formula we had discussed? Given mass divided by the molar mass, then into Avogadro's number. What is the given mass? 46 grams of sodium. 46. What is the molar mass of sodium? Na. Atomic mass is 23 and molar mass is 23 grams. and into the Avogadro's number. And it comes out to be 2 into 6.022 into 10 to the power 23. Just it's an easy calculation, 12.044 into 10 to the power 23. Okay, children, the screen is there for you for a few seconds. You can note it down. Then comes 8 grams of O2 molecule, oxygen molecule. 8 grams of molecules. Same thing. Given mass by molar mass into Avogadro's number. What is the given mass? 8. What is the molar mass of O2? 16 is the atomic mass of oxygen. Okay, molar mass of oxygen 16 grams. 2 atoms of oxygen are there, so it becomes 32 grams. 8 by 32, it comes out to be 1 by 4 into 6.022 into 10 to the power 23, and it becomes 1.5055 into 10 to the power 23. Okay. Now, the third part is 0.1 moles of carbon atom. 0.1 mole of carbon atom. Number of particles, 1 mole of carbon atom has 6.022 into 10 to the power 23. Okay, 0.1 mole means unitary, just into 0.1 it becomes 6.022 into 10 to the power 22. Okay. Now children, we have practiced certain numericals and I hope you have understood, and by doing this assignment also you will have full idea on these numericals. Now children, please take down these assignment. Find ratio by mass of the following combining elements in the following compounds. Of calcium carbonate, you have to find the ratio by mass as we had done earlier. Then magnesium chloride. Okay. Question number 2. Write the molecular formula for the following compounds. You know how to write the molecular formula we have discussed? Calcium and fluorine, nitrogen and hydrogen, sodium and oxygen. Okay. Question number 3. Which has more number of atoms? 100 grams of N2 or 100 grams of NS3. Question number 4. Verify by calculating that 240 grams of calcium and 240 grams of magnesium elements have a mole ratio 3:5. Just calculate their atomic masses, or you can say the gram mass, and then find the ratio. Question number 5. Calculate the number of molecules of sulfur present in 16 grams of solid sulfur. Okay. S8 is the molecule of sulfur. Children, that's all for today. Have a nice time at home. Do this assignment. Be happy, be safe, take care of yourself and take care of the members of your family. Thank you. Have a nice time.